Assalamualaikum and good day to everyone. So for today we will look at about the moment distribution method. This one we will apply this method to analyze the indeterminate beam in purpose to draw the shear force diagram and bending moment diagram. Okay, for this time we will learn how we find fixed end moment, how we calculate distribution factors, df, okay, and k is the stiffness, this one is the total stiffness, how we can carry over the moments, and how to balance it, okay. So the purpose is because we want to draw this one. Okay, for the assumptions, we assume that the clockwise moment as a positive, while for the counterclockwise, we assume as a negative value. Okay, for this example, if you look at here, we know that this beam is indeterminate beam, okay, and the types is continuous beam. Okay, to solve using the moment distribution method, in order to find the final moment, okay, you need to know the fixed end moment. Okay, if you look at here, the beam, we have 2-point loads, okay, but it's not acted at the same position. This 20 kilonewton is acted at the center, okay, and another one is not acted at the center. They acted at 15 and 10 meter distance. So that's why we need to refer to FEM. Okay, so for FEM, we need to refer to these types of tables. So if you look at here, this table is named as the fixed end moments tables. So all this one is referring to the types of load, which is point load only. We also have fixed end moment table for distributed loads. Okay, for these questions, previously we know that we have 2-point loads which is acted at the different distance. So which equation it suits for them? So here we have fixed, here we have fixed roller. So the previously question we have fixed at the end supports. So the picture suit for that is these types. Okay, so we have 3 here. So we know that we only have 1-point load, so this one is not suit for the questions. So we can refer to these two. For the point load acted at the center, this one is suit for that, and another P which is not acted at the center, we can use this FEM. Okay, we refer to these questions. So we have two value of the moments of FEM. So this one is the at the center. Okay, so that's why you need to look at PL over 8. Okay, so for PL over 8, P is a 20. Okay, and then times length of the beam is 25. And then we divide with 8. So we have 62.5. Okay, so for this one. Okay, why we have two different value, negative and positive? This one referring to the directions of the FEM. This one is clockwise, counterclockwise. That's why the value for MAB is negative. And this one is clockwise. So that's why for MBA is positive. Every members, we will have two value of FEM. Okay. And another one, member BC, if you look at here, the equation that suit for MBC, member BC is this one. Okay, so for this side, BC, you need to refer PB power of 2A divided by L power of 2. P is the value of 20. B is the value of this. Okay, so B is 10 power of 2. And then multiply with A, is 15. And divide by length. Length is referring to member BC, which is 25. So you will have negative 48. Okay, and another one is 72. So this one we use this formula. Okay, the value again, the value of negative and positive, this one referring to the sign conventions of the FEM, which is counterclockwise is a negative and clockwise is a positive. Okay, so here we have 62.5 at member AB, and another one negative 48 and positive 72. So basically, every one member, we will have 2 FEM. Okay, after you find the FEM, so then you need to apply to find the distribution factor. So distribution factor is referring to K. Okay, K is 4EI over L. Okay, so for this type, if you are referring to the pictures, we have 2 members. So originally, we have the roller support at the center, right? But we assume the roller support as a fixed rigid due to the location, the positions of the support is at the center. So that's why we apply K for EI over L. Okay, because K is for far and fixed. We also have another formula of K, which is 3EI over L. Okay, this one for the case far and pin. Okay, we can apply this. But for this question, we use this because the question here we have fixed supports at the both end, as well we have the roller at the center, but it acted as a fix. So that's why we have fix and another one fix. So that's why we apply K for EI over L for all members involved. Okay, and then you write in the table like this, which is more convenience. Okay, so we have joined ABC because we have, if we still remember our beam. Okay, so this one is supports referring to A, this one referring to B, this one referring to C. So that's why we have joined A, B, C. Okay, members we're referring to, first, if you look at join A, so we only have okay, if you look at here join A, okay, we have AB, so that's why we have member AB. While for join B, B is located at the center, so it involves BA and BC. So that's why we write here as a BA and BC. And the last one, C, for join C, we have CB. So that's why we have CB. Okay. Okay. When we talk about K, it will related to the distribution factor. At the end of the supports, we have fix. Okay, so normally DS for the fix is 0. Okay, why? Because fixed supports, the degree of the DOF is 0. So that's why we just put here DF as the 0. And while the join B, we need to calculate. In the previous slide, we know that K is a 4EI over L. Okay, so we use that formula in this table. So for EI, L is referring to the length of BA. BA we have 25. Length of BC we have also 25. So that's why it's divided to 25, 25. EI is constant, okay, because it's not given in the question. So by using this 4 EI over L, we will get 0.6 EI and another one is 0.6. Okay. Okay, for the column of total K, K is the total stiffness. So every joints, they will have total K. For joint AC, we don't have because the distribution factor is 0. Okay, so that's why we just have at joint B, which is the total of K is 0.6 plus 0.6, we have 0.32. Okay, okay, so basically the DF, when you do the summations, we will get back 1. Okay, like this. Okay, so that's why the value of degree freedom, they must be 0 or 1. Okay, so meaning that the total of summation must be 0 or 1. This is how you can calculate distribution factor, correct or not. Okay, then this is we call as a table of moment distribution method. This one is a very easy if you do it, listed all the value in the table. So how we listed? First, we know that joints, we have 3 joints, A, B, C. Okay, and this one members is referring to the previous slide. It show AB, B because at the center. Okay, B we have roller, but we assume acted as a fix. Okay, so this one is B, this one is A, this one is C. So BABC is referring to member BA and BC. Okay, so that's why they have like this. And the last one is CB. Okay, DF just now we already calculate in the previous one. Okay, so we have 0. Okay, because this one A and C is fixed, so that's why DF is 0. And this one is 0. And then this one is 0 0.5, is 0 0.5 based from the previous slides. And then moment F is a fixed end moment. This one we already calculate at the first steps. So we got negative 62.5, and BA for fixed end moment is 62.5. Fixed end moment for BC is negative 48. Okay, so basically this value we can find it. Okay, now how we can balance it. So if you look at here, the green colors is referred balance the fixed end moments. So if the value of fixed end moment is negative, make it as a positive. So that's why here from negative we make it is positive. Okay, as well this one is positive, we write in the bracket as a negative. Okay, how about this one? How negative 14? It can be negative 14 because we multiply 62.5, we do subtractions. Okay, 62.5 minus 48. So we have 40.5. Okay, this one. We do the subtractions lah, this one. So we have positive 14.5, but in the bracket we write opposite from positive, which is negative. Okay, then the balance of it we do and the next row. Okay, this one is 62.5, we multiply with the DF, so that's why we got 0. And this one negative 42.5, we multiply with the DF 0.5. Okay, referring to this, so that's why we have 7.25 negative because we multiply with the value of bracket. So that's why we have negative 7 at the both sides. Okay, and this one is 0 lah, because 72 times with 0 times df, we will have this one is 0. Okay, now how we can carry over? Okay, try to look at this one. So if you look at here, we carry over from one joint to another joint. We cannot carry over at the same joint. That's why if you look at here, we don't have negative 7.25. We don't carry over to next. No, because this one is same B joint, the same joint. So that's why carry over only carry over to the another support. So B we can carry over to A, and another one B we can carry over to C. Okay, so that's why we have arrow like this. So 7.25 we divide by 2. Okay, so we have 3.6 negative, and this one also negative, and this one C we can carry over to support C. Okay, so that's why if you look at here, the value is 0. So because the origin value is 0. Okay, then you do the balancing. Okay, so this one is negative, so in the bracket will be positive. This one 0 0, so this one is nothing, 0, and this one is negative value, this one in the bracket is positive. Okay, then you do the summation for the balance. Okay, so how to do the summation? Negative 3.63 plus 3.63 is 0. This one of course 0. Okay, and then a negative 3.63 plus 3.63 we have 0. Okay, when you look at this row, we don't have anything to carry over because of the 0 value. So this one, we stop the calculation at this. So how we can calculate the end moment? So if you look at here from the negative 62.5 minus 3.63, so we have negative 66. Okay, and this one we do the summation for all this. Okay, so 62.5 minus 7.25, we will have 55, and this one should be same value but difference convention, positive and negative. And this one 72 minus 3.62363, we will got 68. Okay, so that's why the how we can calculate fixed end moment. So from all these fixed end moment, you can now find the support reaction for each members A, B, and BC. Okay, so you look at the next slide. So this is when you write in the proper way. Okay, so that's why we have here. This one is similar to the previous slide. Okay. Okay, how to calculate support reaction for indeterminate beam? Okay, so previously we know that our beam is fixed at the both ends and a roller at the center. To calculate the support reaction, we need to analyze member by member. That's why here we have two members, which is member AB and another one, member BC. Okay, so then you need to draw one by one. So this one, if you look at here, I only draw member AB only. Okay, and this value we got from the table of MDM as well, this one. Okay, so from here we can find support reaction at A and support reaction at B. This one will be the normal calculation, how we can calculate the support reaction. So you just take the moment at A or B, so you can find the support reaction at B and A as well. And then consider another members, which is BC. Okay, so this one you need to draw all the fixed end moment. Okay, this one is compulsory because we want to draw the support reaction. Okay, so this time we can find support reaction at B and C. Okay, using the moment equation. Okay, so how to draw? Okay, after we got all the value, this is the value of support reaction. Okay, this one we got two value because just now we have member AB and BC. Okay, so that's why we have two value of support reaction VB. Okay, and the last one is VC. After you got all this value of support reaction, then you can draw shear force diagram and bending moment diagram. Okay, so the method is previously similar to the mechanics of materials, okay, in chapters shear force diagram and bending moment diagram.